a software engineer, so I'm working on some cryptography stuff, multi-party computation. So when we have like separate agents independent of each other, they need to communicate at some point in time and gain some common knowledge, which we could simply call like the shared public key. These agents could connect with each other and then do some actions. I'm mostly like working on the implementation of such kind of protocols. Yeah. If we're talking about MPC, well, it's again something that we would like to distribute the trust, right? We have like many participants, so you could do some kind of multi-sig here as well. Basically, you are distributing your trust. You are not allowing the single point of failure in that sense, and you can keep your funds like safely, not controlled, but it would managed by smart contracts. How it's directly connected to this Blockswap. Well, MPC is like, as we name it in Blockswap, it's like polygrain of cryptography. There are like multiple of use cases which can be used within the multi-party computation, because you could probably set any scenario you want. So you just have like multiple agents and it's fully permissionless system. They could enter the protocol, they could quit protocol, so at any time they would like. So no limits here. So imagine you have a validator, and so when it's registered in the Ethereum deposit contract protocol, and if he would like to join the Stakehouse protocol, this protocol developed by Blockswap, he could encrypt. He could encrypt its BLS signing key, let's say, on this shared public key of these committee members, of these MPC solvers. So these are necessarily the agents that are performing these computations or over some data. At some point of time, if you would like to recover the key, maybe you are not in the place of where you're running the validator, maybe, or maybe some other scenario. So in our protocol, there is the naming of node, which is basically when you run a validator with several entities, right? And when some entity is unable to perform some duties, so then the other guy who like jointly on this validator, he could step in and do this operation. That's why we need the key recovery here, and that's why the MPC is here in place. You know that at a single point of time you have like only one owner, I mean only one key, but they could jointly own it, right? And you can at some point of time switch them if something went wrong. So it's really enjoyable, you know. So when you are doing something and you are just having a hypothesis, you have some reference implementation, and you bring it to production, and it's working. All the algorithms that we are using now, they were kind of researched and implemented like a while ago, like in 1980s or sometimes. So recently they gained like a big traction, I would say, from the community. Blockchain is not like the last thing that kind of moving these technologies forward. So from that perspective, the like cryptographic schemes get better researched and get like better traction from all of the community. So I would say blockchain technologies moves forwards. The cryptography is not like keeping it at the same place yet. As long as you have like several participants in this validator, so no problem. You can just take the control over that and just do the things. Not only you could recover like the key of the validator, you could also like make the committee switchable. This is a little bit different concept. So you have these MPC solvers, and as I said, since this is a fully permissionless protocol, so these guardians could enter anytime, they could quit it anytime, and etc. What we are introducing here, we have some kind of handover. That means that we could switch even the committees. So at some point of time, your requests are processed by one committee, or like a set of these MPC solvers, while we change the set of these MPC solvers. One of them, for instance, is going. It's no longer the member of this protocol. So you could simply like switch the committee, and requests would be processed by this new committee. So this is DKG public key that was previously distributed among the initial participants, it's kept the same. So it's a seamless interaction even within the users. So from the user's perspective, you even don't need to know that's okay, the committee got switched or something else. So you just keep going and doing your action. Yeah, so currently we have initial deployment of 20 like MPC solvers. These are both on Girly and on mainnet. Anyone can join unless he possesses at least one collateralized slot token in the Stakehouse protocol. If we are talking about this like special case, anyone could join and be the part of the solver community, let's say. If you are joining the Ethereum deposit contract via our protocol, you got the ETH token and slot token, and just entering the Stakehouse protocol, and you can do like your work. Yeah. Within the slot tokens, you can, this is a kind of a sign that you own the validator, and then you can indeed perform some validator operations. You can run MPC solver by yourself. That's the first option. The collateral slot is non-transferable, so which means that you are entering here. Basically, we have a collateral slot, right? And it's not transferable, which means that if you are joining the protocol, so you are here, you would like to run a solver, you could do this definitely. If you don't want, so you just not running the solver. Yeah. Given 32 ETH, you get in 24 ETH and 8 slot tokens. Basically, this means that you have the same value for this 24 ETH as you would have for 32 ETH, right? So regarding the MPC, it's definitely unique. You could use MPC in general for whatever data you want to work on. But for the current case regarding the Stakehouse, in that terms, it's kind of unique. Yeah, if you're located like far away from the place where you are running it, and you need to do it ASAP, so you could do it right away, just like send in the key recovery transaction. These MPC solvers would process this data. They would do some computations over this. And also, please note that MPC solvers do not have access to this data. They're just doing some computations over encrypted data. So the only entity who will be able to recover it's the requester who is valid for this key recovery process. So the solvers are just doing some computations. They're doing them in off-chain manner and pushed the results back to the smart contract. So the smart contract is kind of the source of trust, the intermediary in terms of where we are pushing data and fetching them back. The requester could then again aggregate this data, again do some other computations, and recover the initial key. This is kind of usability feature, right? But it could be applicable in several scenarios. If something going wrong within the validator, it's failing. So anyone who is a part of this validator could just step in and take control over that and just trying to perform its duties better. For now, in this Stakehouse, we do not have. At least it could be from the external sources or something else. But we could integrate these CIP computations within the other protocols, the Blockswap protocols like Keto and etc. that are currently being developed and will be they will be shipped. Yeah, we are just thinking about basic scenario. What's the basic motivation of the guardians to do this job? That's a good question, and we are currently not investigating, but we are finding the right business model in order to do this correctly, right? Because no one would like to do something for free. Yeah. In terms of handover, you could switch the committee. So if some guys would come and say, okay, we would like to run guardians as well, we are happy to get them on board and just do the handover procedure, and they're in the game, and
then they become the NPC solver.
Yeah, correct. Yeah, correct. Okay. So no issues here. So it's just you are running the handover procedure, and you enlarge your committee, or maybe you completely switch them. So there are one set of members and then you are switching to completely new set of members. So it works like in both cases. Working on the cutting edge set of technologies where I can like develop some new things on top of already known cryptographic protocols, and you can move that to some sort of production and see that it's used by users. And I enjoy doing some things in practice, because cryptography is very theoretical science, right? But it's also a practical one. So we should always like keep in mind like how to make this applicable. Makes me like think in maybe not ordinary way. Yeah. So you need to be creative to fulfill like all of these products to make them go. Yeah.